Over the past few decades, wild boars have expanded their presence across multiple continents, with populations now exceeding 30 million globally. This rapid spread has turned them into one of the most formidable invasive species on Earth. Known not only for their aggressive behavior, wild boars have also demonstrated increasing intelligence, making them more difficult to manage with each passing year. The damage they cause to agriculture and natural ecosystems is estimated in the billions of dollars annually. Various control methods have been employed to reduce their numbers, including aerial management, toxicants, and steel corral traps. However, despite these efforts, their population continues to surge, seemingly defying every method used to contain them. This raises an urgent question. Is there a fundamental flaw in current trapping strategies that allows them to escape and multiply? This ongoing conflict represents more than just a wildlife control issue. It is a battle with potentially devastating environmental and economic consequences. Researchers and wildlife managers are now turning their attention to perfecting wild boar traps. Understanding the behavior of this species is key to designing systems that are both humane and effective. Simultaneously, the global farming industry has started to transform these highly adaptable animals into a valuable agricultural commodity. In the United States alone, more than 9 million wild boars are now present. To visualize their scale, this population would require a landmass larger than the state of Texas if gathered in one place. Their origins can be traced back to the 1502, when explorers and settlers introduced Eurasian wild boars to North America for food and sport hunting. Over time, some of these animals escaped captivity, crossbred with domestic pigs, and evolved into a more robust, adaptable hybrid species. This hybrid is capable of causing massive agricultural destruction, with some reports indicating that a group can damage up to 3 hectares of crops in less than an hour. Lacking natural predators, and aided by their high reproductive rate, these animals have rapidly spread. As their numbers climbed, traps emerged as a key method for controlling populations. However, in recent years, many of these traps have proven ineffective due to poor design, incorrect placement, or misuse. One of the most common errors involves the size of the corral trap. A trap that is too small may capture only a portion of the group, commonly referred to as a sounder, allowing the rest to escape and learn to avoid traps in the future. Modern corral traps are generally circular in design and constructed with a steel frame. The optimal size ranges from 9 to 12 meters in diameter and about 1.5 meters in height. These dimensions are sufficient to hold between 15 and 30 wild boars in a single event. Another crucial factor is durability. Wild boars are powerful animals. Adult individuals can weigh up to 200 kilograms and stand nearly 1 meter tall. They have been known to ram enclosures with enough force to damage poorly built traps. To withstand such pressure, traps must be constructed from high tensile steel and securely fastened with professional-grade welds or bolts. Nonetheless, some cost-conscious landowners continue to use materials like wire mesh, wooden posts, or chain-link fencing. These are often not strong enough, and, worse yet, may teach the animals how to identify and exploit structural weaknesses. The gate mechanism is perhaps the most decisive component of any wild boar trap. It should be made of strong steel and feature a fast-acting, sliding, or drop-style design. Reinforcement at the base is necessary to prevent animals from pushing their way out. One of the most effective systems currently available uses a remote-controlled drop gate integrated with cameras and motion sensors. This setup allows the operator to observe the herd from a distance and trigger the gate only when all individuals are inside, thus avoiding premature closure. Even with the best trap design, success still depends heavily on trap placement. In fact, location can influence up to 60% of the outcome. Many trapping efforts fail simply because the trap is set in an area with little to no wild boar activity. Since these animals are primarily nocturnal, with peak feeding occurring between 8 p.m. and 4 a.m., traps must be placed in zones showing consistent nighttime movement. Beyond containment, there is growing interest in converting the wild boar challenge into a sustainable opportunity. In several regions, captured wild boars are being redirected into controlled farming operations that contribute to the meat production industry. However, Effective trapping remains the first and most essential step in both population control and commercial utilization. If left unchecked, wild boar populations can grow exponentially. Without removing at least 70% of the population annually, reproduction rates spike. Females can produce litters of 8 to 12 piglets, and the young reach reproductive maturity in just a few months. This makes the species one of the fastest reproducing invasive mammals in the world. Ultimately, the fight against wild boars is not just about wildlife management, it is about protecting agriculture, ecosystems, and economic stability. A single mistake, whether in trap design or placement, can allow this species to further entrench itself in the environment. Learning from past errors and applying precise strategies is the only way to turn the tide in this ongoing battle. Ideal trap locations are typically situated along footpaths marked by visible tracks, areas of disturbed soil, wallowing sites, bedding grounds, or routes that connect dense forests with nearby farmland. These corridors are frequently used by wild boars as they discreetly move in search of food. Once a trap is properly installed in such an area, the next critical phase involves attracting the herd into the enclosure voluntarily and without suspicion. This is the purpose of baiting, transforming a cold, mechanical structure into a biologically appealing and seemingly safe environment. Although bait formulations may vary, the most effective and widely used combinations often include dried corn, expired milk or sugary beverages, beer or yeast, and fruit jelly or gelatin. These ingredients are thoroughly mixed, sealed in a plastic container or durable bag, and allowed to ferment for 3 to 5 days. The fermentation process is typically conducted in shaded areas or beneath straw, helping maintain warmth and shield the mixture from direct sunlight. The resulting scent is powerful enough to attract wild boars from long distances, while also encouraging them to stay and forage, thus setting ideal conditions for trap engagement. The strategy of bait distribution plays a vital role. The process usually begins by scattering bait outside the trap, gradually creating a trail that leads toward its center. Each night, the bait line is moved closer inward. This step-by-step method encourages natural behavior and minimizes suspicion, helping the animals grow increasingly comfortable entering the enclosure. In some cases, trappers bury the bait in shallow holes about 20 to 30 centimeters deep rather than placing it on the surface. Burying the bait helps spread the scent farther and maintain its potency over time. This also stimulates the animal's instinct to root, which prolongs their presence within the trap area and strengthens the illusion of a natural feeding spot. The baiting phase typically lasts between 3 and 7 days, depending on the herd's behavior and response. During this period, the trap gate remains fully open, allowing unrestricted movement in and out of the structure. While it might appear to be the right moment to activate the trap, closing the gate prematurely can result in capturing only a few individuals while alerting the rest, causing them to avoid the location in the future. Conversely, waiting too long may lead the group to abandon the area altogether and establish new feeding grounds elsewhere. To avoid these risks, herds are monitored closely using infrared cameras or motion sensors. Once 70 to 90% of the group begins consistently entering the trap over several consecutive nights, the optimal moment for activation has arrived. When the gate finally drops, the enclosed wild boars often react with intense panic. This moment marks the culmination of a carefully planned strategy requiring precision, patience, and tactical foresight. Inside the enclosure, the animals may run erratically, collide with fences, attempt to climb, or try to break through the mesh. For this reason, immediate response after the trap is triggered is essential. Ideally, a capture team should arrive on site within 1 to 2 hours. Any delays can increase stress among the animals and heighten the risk of injury or damage to the trap structure, especially if it is not built to withstand such force. Delayed response can also cause the remaining herd members to become wary, making future trapping efforts more difficult. Despite its effectiveness, the corral trap has certain limitations. Its construction demands a significant initial investment, often 3 to 5 times more than simpler trapping methods. It is also relatively large and labor-intensive, with much of its success relying on human intervention and technological support. In most cases, humane culling is necessary. However, in some regions, successful trapping operations have occasionally concluded with communal cookouts, provided food safety standards are met, offering an unexpected benefit after a complex and demanding process. While some countries continue to face serious challenges in managing wild boar populations, others have turned the issue into an opportunity. In certain parts of Asia, wild boars are being integrated into sustainable agriculture models. With proper care, even the most untamed animals can be raised to adapt and thrive under controlled conditions. The domestication process, however, hinges on three essential factors: natural instincts, habitat conditions, and genetic traits. Neglecting any one of these aspects can undermine the entire domestication effort. Directly domesticating pure wild boars is often impractical due to their strong reactivity and resistance to confinement. To address this, farms typically use crossbreeding methods, pairing wild boars with domestic pigs to create hybrids. These hybrids maintain the muscular build, thick fur, and rich flavor of wild boar meat, while displaying more manageable behavior, lower aggression levels, and reduced enclosure damage. The second key factor is the environment. In China, semi-wild farming models are commonly employed, where boars are raised in expansive, enclosed areas covering thousands of square meters. These environments are designed to closely replicate natural habitats, helping reduce stress and support instinctual behaviors. Wild boars enjoy wallowing in mud, which helps regulate body temperature and repel parasites. Farmers encourage this behavior to promote health and well-being. Instead of relying heavily on antibiotics, disease control focuses on hygiene, daily observation, and the use of herbal remedies. Each animal is assigned an ERID, electronic identification, for monitoring purposes, ensuring traceability, health tracking, and outbreak management. After a rearing period of 10 to 12 months, most animals reach weights of 60 to 90 kilograms, about one-third the size of fully grown wild boars, and are ready for market. The meat is firm, flavorful, and in high demand, often selling at prices up to 3 times higher than conventional pork. Each year, these farms supply approximately 100,000 tons of premium meat, consumed both domestically and across other Asian markets. Once seen solely as a destructive, invasive species, wild boars are increasingly being recognized as a potential resource. This transformation is prompting a broader reevaluation of how to manage, coexist with, and benefit from one of the world's most resilient animals.